everyone, this video is about solving exponential and logarithmic equations. First strategy is to raise both sides with the same base. For this question here, we have to use the base 3 to the power of, 3 to the power of, because on the left it will cancel out, so we have only x equals 3 to the power of 7, which is already the solution. Now for this example, it is best to first combine the ln. So we have ln 4 over x because of the quotient rule, and then now we can erase both sides, and the base we use must be e, because e to the power of ln, e to the power of ln cancel out. We have only 3x minus 5 equals 4 over x. Of course, if you multiply both sides by x, we get this, which is a simple quadratic. 3x squared minus 5x minus 4 equals 0, and you can factorize this. Minus 12 minus 5, minus 6 plus 1, x minus 2, 3x plus 2, 3x squared, minus 6x plus 2x, minus 12, minus 5. Actually, it's not factorizable. Yeah, it's not factorizable, so we have to use the quadratic formula then. The x is therefore 5 plus minus square root b squared, so 25 plus 4 times 4 times 3, 16 times 3, 48, 25 plus 48, 673, all over 2 times 3, 6. Okay, next we have an exponential, so we have to log both sides. In this case, we have to use a base 2, because the exponential is with the base 2. In order to cancel out the 2 here, we have to use base 2, because now we have only x equals something, which is already the answer. Log 3 base 2 is the answer. And here there are many ways to do this, but I think the best way is to just first we split this power 3 to the power of 1 times 3 to the power of minus 2x equals 5 to the power of x, which means we have 3 to the power of minus 2x over 5 to the power of x equals 3 to the power of minus 1, and this means we have 3 to the power of minus 2 over 5 all to the power of x equals 3 to the power of minus 1. And now we log both sides, so the base must be 3 to the power of minus 2 over 5, of course. Both sides, we also log 3 to the power of minus 2 over 5 on the right, and therefore they cancel out, and we have the final answer. X equals log 3 to the power of minus 1. The base is 3 to the power of minus 2 over 5 in exact value. Yeah, just use a calculator. And now we have 4, which is actually 2 to the power of 2, again to the power of x. Yeah, you still have the rest of the equation. And when we have power to a power, we can multiply, which is equal to 2 to the power of 2x, and that's also equal to 2 to the power of x again to the power of 2, same thing. It's also 2 to the power of 2x, same thing. So this means we have a quadratic in terms of 2 to the power of x. and this is the same as x squared. Okay, this is the same as x squared plus x minus 2 equals 0, which can be factorized, and we will get x plus 2x minus 1 equals 0, which means the x can be minus 2 or x can be 1, and therefore 2 to the power of x equals minus 2 or 2 to the power of x equals 1. And now we log both sides, we get x equals log minus 2 base 2, which is of course rejected. The argument cannot be negative, it cannot be minus 2. If you use a calculator, you get a math error. And here you get log 1 base 2, which is 0 actually. So the only answer is 0. And here, if we just multiply throughout by 3 to the power of x, we get a quadratic in terms of 3 to the power of x, because you have 3 to the power of x squared plus 27, just 27, equals 12 times 3 to the power of x, which is a quadratic because it's the same as minus 12 3 to the power of x plus 27 equals 0. So this is like a squared minus 12a plus 27, which is factorizable, and we get a minus 9a minus 3, and this means the a can be 9 or the a can be 3, and the a is 3 to the power of x. So 3 to the power of x equals 9, 3 to the power of x equals 3, and x is therefore log 9 base 3, which is 2, and here we have x equals log 3 base 3, which is 1. Two solutions. And now remember to check solutions using the original equation. So here, if you use e to the power of e to the power of, we cancel out, so we simply have x squared equals x, which means it's like x squared minus x equals 0, and we can factor out the x times x minus 1 equals 0, which means the x can be 0 or the x can be 1. But if you plug in, you'll get 0 squared, which is 0, and the or here you get just ln 0, which is impossible because it's gotta be positive. The argument must be positive, so this is rejected. We have only one solution, so you have to reject the impossible here. And here, if we maybe put the 2 here, so we have ln x squared equals ln x plus 6, and we can raise both sides base e, cancel out, so we have simply x squared equals x plus 6, and we can move everything to the left and factorize x minus 3 x plus 2, and x equals 3 x equals minus 2. But as you can see, when you plug in minus 2 here, you'll get an error, so this must be rejected. Now remember that we have to check using the original. If you check using this equation, well, minus 2 squared is 4, so it's acceptable, but this is not the original equation. This is the original equation, so we have to check using the original. Alright, that's it. I'll see you again next